Good morning, everybody. Thank you for joining today's presentation on Elastic SIEM. You'll hear from several folks from the Elastic team about the introduction of Elastic SIEM and where we're taking it next. First, allow me to share 3 logistical notes. First, if you would like to ask a question or give us feedback, you can do so by clicking the chat button on the video player. Second, we want you to be able to see exactly what our presenter is showing. To ensure that that is possible, within YouTube, make sure that you're viewing a high resolution view of our screen share. And lastly, be advised that a recording of this video will be available following the webinar. So with that, let's get rolling. So we are here to talk about Elastic SIEM. And over the last several years, we've been making it easier for users to use the Elastic Stack for security analytics. We define security analytics as the highly scalable collection, indexing, and real-time analysis of all kinds of security-related data. That is the purview of security analytics as far as we're concerned. Today, we're here to help you understand how we're supporting our SIEM-type use cases. But first, let me share some quick context. We all know that Elastic is a search company, and it turns out that security analytics and security information and event management specifically, SIEM, it thrives on the type of search capabilities that the Elastic Stack provides. In fact, security analytics has been one of our fastest growing use cases. Folks like Bell Canada and Slack use the Elastic Stack for security analytics. Cisco Talos, no small enterprise, they use Elasticsearch at the heart of their threat hunting program. OmniSOC, which is led by Indiana University and supports several Big Ten institutions, OmniSOC and Oak Ridge National Laboratories, they're just a handful of the organizations that use the Elastic Stack as the core of their SIEMs. This widespread community adoption, this is what brought us to explore how we could help with security analytics further and help with SIEM specifically. So allow us to introduce Elastic SIEM. This is our first official step in building our vision of what a SIEM should be, and we're focused on helping with multiple different use cases. The first is SIEM broadly, security information and event management. Obviously, that has many different sub-use cases within it. One of those is threat detection. That's a key area of focus, as well as threat hunting, an area where the Elastic Stack has long been used and where we think that we can provide even more support. To deliver Elastic SIEM, we start with the capabilities of the Elastic Stack, many of those that you already know and love. Then we add new integrations for security data sources. Think beats and log stats modules to power your ingestion and your parsing. Then we bring in Elastic Common Schema so that you can build your data models on uniformly parsed data. Then let's open the new SIEM app, which operates within Kibana to bring everything together. And finally, enrich that app with the security content that will be provided by Elastic and by our community. At the heart of Elastic SIEM is the SIEM app. This is an interactive workspace for security teams to triage events, perform initial investigations, and do other types of work. It's Timeline Event Viewer. This is what allows analysts to gather and store evidence of an attack. Analysts can pin and annotate relevant events, comment on and share their findings, and do everything all within Kibana. The Elastic SIEM app is what allows you to make easy work of this type of work, and it supports any data that follows the ECS format. Here at Elastic, we strive to move fast, we strive to release often, and we strive to deliver a constant stream of value to our users. And so right before we actually get to see Elastic SIEM hands-on, I'd like to share where we're coming from and where we're going. I mentioned at the top that we've been focused on supporting the work of security organizations for several years. In recent years, we've introduced Elastic Common Schema. This is what enables the normalization. This is what prepares the data for uniform analysis. As we described above, we've introduced a number of new modules. You'll hear in just a moment from Andrew Kroh, member of our Beats team, who can describe how we're helping ingest and prepare that data for sources like Suricata, Zeek, NetFlow, the Linux Audit Framework, and several others. I've told you about our new SIEM app. You'll see this presented by Mike Paquette, and then you'll see a deeper dive delivered by Andrew Goldstein, one of the developers who designed and built that solution. Medium term. Our journey includes enhancing our SIEM solution. We'd like to include new SIEM detection rules, more data sources, and we'll have more details about that coming soon. And finally, longer term, we plan to add threat intelligence. We plan to add, we hope and expect to add user and entity analysis capabilities and more. So let me turn it over to Andrew Kroh to see the standing up of Elastic SIEM and the ingestion and preparation of data. Andrew.
Hi, my name is Andrew Kroh. I'm a member of the SIEM team at Elastic, and I'm one of the software developers on the Beats project. I'd like to show how you can run the SIEM app and start ingesting data. I'll be using Elastic Cloud to host my instance of Elasticsearch and Kibana for this demo. Another option would be to just download Elasticsearch and Kibana and run them locally. You can use Elastic Cloud. It has a 14-day free trial, and it always has the latest versions of the Elastic Stack available to run. To send data into the cluster, I'll be using Beats, which are agents for shipping data to Elasticsearch. You can use Beats, or you can bring your own data. The important thing is that the data be structured based on Elastic Common Schema, or ECS. The SIEM app is built around ECS. So let's take a look at what curated integrations we have in Beats. So for collecting host data, you'll mainly be using AuditBeat, FileBeat, or WinLogBeat. AuditBeat has a new module for collecting system information. It gathers the packages that are installed, the processes that are running, user login, socket connections, and users that are registered on the system. It also has the AuditD module, which is specifically for Linux for receiving kernel audit events. And it can also do file integrity monitoring. FileBeat has modules for parsing system logs, has a module for parsing the OS query output and Google Santa logs. And WinLogBeat is the beat for ingesting Windows event logs. And in 7.2, we added a module that understands sysmon data and converts it over to ECS. And for network data, we have Paquette, which can send flow metadata to Elasticsearch. And we have protocol analyzers for DNS, TLS, and HTTP. And in FileBeat, we have several integrations. It can parse logs from both Zeek and Suricata, which are network security monitoring tools. It has a syslog input and can receive logs directly from Cisco ASA, Palo Alto PAN-OS, and Ubiquiti devices. It has a NetFlow and IPFix input to capture flow logs. And for Kubernetes users, it can parse core DNS logs and Envoy proxy logs. And coming in 7.3, we're adding a module for VPC flow logs coming out of Google Cloud. And if you want to bring your own data, we have ECS. So this defines a common set of fields to populate when you're ingesting your data. And and because of this normalization, it enables you to analyze data coming from many different sources. And ECS, we are adopting it across the Elastic Stack. So we've been updating all our beats to produce ECS data. And you can collaborate with us on ECS through our GitHub repo. All the documentation for the fields are available on our website. So if you want to browse the schema, just head over to elastic.co and click on the ECS docs. So now let's get into deploying the stack. Like I said, I'm going to use Elastic Cloud. I've already signed into the Elastic Cloud console, so I'm going to click on Create Deployment. We're going to give it a name. I'm going to deploy this on AWS, so I'm just going to leave everything as is. Click Create Deployment. And the deployment's going to be ready in about 3 minutes. So I'm going to use one I deployed before the webinar. First thing I'm going to do is launch Kibana, because we're going to need that later. And then next, I'm going to copy this Cloud ID. This embeds the URLs to Elasticsearch and Kibana. And we can use this in our Beats configuration file so it knows where to send data. So now I will open up a new Linux machine I just deployed. And what we're going to do here is we're going to install both AuditBeat and Paquette. We're going to download them from the website. And we're going to install the Debian packages. Next, we'll take that Cloud ID that I copied off of Elastic Cloud Console and append it to the configuration files. And for AuditBeat, I have one extra thing to do. It ships with some sample rules for the Linux kernel, and we're just going to enable those. And now the configuration's all done, we're going to run the setup commands. And what these do is reach out to the Elasticsearch instance and Kibana. It sets up the index lifecycle management rules and the index template, and also installs the dashboards to our cluster. And once those complete, we will start the services. So now AuditBeat and PacketBeat should be running on the system. By default, the logs end up in Journal D, so we'll just open up Journal D real quick, do a quick sanity check. Looks like everything's good. So now we should have data in Kibana, so let's head back over there. Okay, here in Kibana, the way I usually verify that I'm getting data is to open up the dashboards. So let's open up the dashboard that comes with AuditBeat. So it looks like we are getting data, and you can even see the journal command I ran to check the logs showing up. Let's also verify that we're getting PacketBeat data. We'll open up the DNS dashboard. And yeah, we're starting to get some data. This has all the queries that have been run from the server, the DNS queries. But now with the SIEM app, which you can get to from the left-hand nav bar, there's an easier way to do this. Right here on the overview page, we can quickly see that we are getting host data from AuditBeat, and we're also getting network data from PacketBeat. And if you were to bring your own data, you need to go into the Kibana Advanced Settings and tell the SIEM app which index patterns to use. So right here in Advanced Settings, we will scroll down to the SIEM area, and in here you would just append, say log-stash-star, and click Save. And then the SIEM app would now be looking at your log-stash indices. So I've shown how easy it is to get Elasticsearch up and running and start ingesting data with beats. Now I'm going to hand it over to Mike, who's going to show you how to start making sense of your data.
Thanks, Andrew. Thanks for showing us how easy it is to get Elastic SIEM up and running in Elastic Cloud's Elasticsearch service. Next, I'm going to walk through a demonstration that shows a number of ways that a security operations team can use Elastic SIEM to defend its data and its infrastructure against attack. Just to set the context, remember, as Mark described a few minutes ago, Elastic SIEM is not a separate standalone product, but rather it builds on the capabilities of the Elastic Stack that you already know for security analytics. It includes things, search, visualizations, dashboards, alerting, machine learning features. It also includes the growing list of out-of-the-box integrations that Andrew just described, as well as hundreds of community integrations. And as we've discussed, now it includes our new SIEM app, which was released in version 7.2 of the Elastic Stack as beta. And the SIEM app is available under the Elastic Basic license level, which means it's free for end users. In today's demo, Swift Crypto is a fictitious company that we made up just for this demo. You can think of them as a financial transaction processing company of some sort. And Swift Crypto uses the Elastic Stack as their SIEM, and they've recently updated to version 7.2, where they can now use the SIEM app as part of their SIEM solution. And they've got a pretty comprehensive set of logs being ingested into Elasticsearch. They're using AuditBeat, FileBeat, PacketBeat, Logstash, and even some REST API calls to get data into Elasticsearch. And they're collecting events from a variety of sources. Their web servers, SSH logs, web application firewall logs, DNS, email, host intrusion detection. So they've got a nice set of security relevant events coming in. They also ingest some threat intelligence in the form of malware IPs, as well as certificate information that they get from Cloudflare, and Let's Encrypt. They've also implemented the Hive, an open source tool for security incident response. And so it's a pretty nice integration of Elastic SIEM for their security operations teams. So within their Elastic SIEM, they've implemented a number of SIEM detection rules that are using Elastic's alerting features. You will refer to this as Watcher, and they've integrated the notifications from these alerts into their company's Slack instance. So during the demo, we'll be looking at their Slack messages as a way to track their efforts to defend against this attack. So it turns out that Swift Crypto has a disgruntled ex-employee who was recently dismissed. This person was a developer at Swift Crypto, but then left the company. They have knowledge of both the infrastructure and the security processes. And this person has launched a reasonably sophisticated attack against Swift Crypto in order to ultimately gain access to privileged employee accounts and ultimately do harm. The attack includes a number of different alerts. One would be a smokescreen alert that we'll talk about in some detail, a stop or crash service, a login using leaked credentials, and ultimately the creation of a fake website for phishing credentials from privileged users. We think the attacker's end goal was to blackmail or extort money from the company. So we're going to be taking a retrospective look at what the Swift Crypto team did to defend against this attack or these attack activities as they happened. So in order to do that, I'm going to move on to a screen that I'm going to make this larger, and hopefully you can see that. This is the Swift Crypto Slack team. And one of the things that we'll look at is, let's start right here. And first of all, before we get into any details, let's just take a look around. These Slack notifications are interesting. So what they've done is they've configured their Elastic watches to output the results of the watch to to a Slack message. The title of the message is actually a hyperlink back to Kibana, where the time of the event that took place is encoded into the URL. So when we click on it, we'll be looking at the right time to start our investigation. We've also got some other relevant details. In this case, things like the web URL and the HTTP method. Of course, we've got things like the source IP that identify the system on which the event occurred. And finally, in some messages, we actually have a link to the relevant incident case, like the one I'll show down below. We'll go to that when we get to the next event. So the first alert they received was related to what I previously called the smokescreen attack. The attacker is aware of that the Swift Crypto security team checks for information in their logs, like credit card information. The idea being, if there are any logs coming in from the web server that contain credit card details, this would potentially put their PCI compliance at risk. And so the attacker set up a script that would start writing credit card data to the portal, and he knows that the security team will be looking at these logs when this is detected. So he's hoping to distract them with that activity so he can carry out the rest of his particular mission. So we see the alert message at the top saying a possible credit card number has been detected in the customer portal. This alert was generated by Swift Crypto's web application firewall, which is a mod security. So the hyperlink in the Slack message will take them into the web application firewall dashboard in Kibana. So let's take a look. I'm going to go ahead and just click on that. This will open up the Kibana instance, the Swift Crypto Kibana instance, and of course we're gonna be landed right off the bat. Let me make sure this is quite visible here. I'm going to make that bigger. Okay, it lands us on a web application firewall dashboard. We see the time period is about a 40-minute time period. And the first thing we notice is we had a significant number of attacks reported by the web application firewall during this time period. Geographically, they all seem to be centered around somewhere near the UK. And on this dashboard, we have a lot of other information. But one of the things that we can see down at the bottom is we have a table of all the events that are being generated by this web application firewall. We're seeing a lot of attempts for logins. We're seeing a lot of 404 response codes coming back. Why don't we dig in and take a little closer look at one of these events to see what we can learn? So if I just expand one of the events at the bottom of this table, and I'm going to click on the View Single Document view so we can see this a little bit better. One of the first things that we see here is that you see by the index name, this is an Elastic Common Schema format. Quick indicators, you can look for a field called ECS.version. That tells us that this event is represented in Elastic Common Schema format. We do see that the events is coming from mod security, which is nice. Right below that, as I mentioned earlier, some good ingestion time enrichment was being done. And so the IP address associated with this event was looked up against a malware list, a malware IP list. And in this case, it came back false. So this attack was not from an IP address that was known to be bad. We also, if you see down below, when I get down to by the sources, we've got a lot of geo information that tells us where the attack was coming from. In fact, this was from London. We have the ASN information. We know it was from DigitalOcean. And one of the things that is analysts like to look for during an attack is to see whether or not this attack might be automated. And if we go down to the user agent fields, one of the things that we do see here is that I see a user agent claiming to be Kroh. So this gives me an indication that this attack might be associated with either a command script or a set of automated tools that might be instigating the attack itself. Now, we don't see the credit card information in here, so we assume that it was either in the URI of the request or in the post payload, neither of which is being recorded here. And at this point, keep in mind, we had no idea that this was a smokescreen attack. So we went ahead and blocked the source IP address of this attack. This is a pretty cool feature of Kibana where we used a scripted field to call an API endpoint that is responsible for blocking the IP. You'll actually see it up here at the top. We've actually got a take action field. And if I click on this, it's going to hit that API endpoint that will let us know that it's basically gone off and blocked that address. So it's made a call to the server itself to block any further requests coming from this source IP address. So let's go all the way back to Slack. And the next thing that we see is an event down below, which says it's a low count of audit beat events. So as you saw Andrew install Audit Beat grabs a number of pieces of information from the system upon which it's running, packages them up in events, sends them across to Elasticsearch in ECS format. In this case, the Swift Crypto team deployed an Elastic machine learning job to do what's typically called log continuity monitoring. So before you get to fancy detections, it's best to just know that your logs haven't been interrupted or stopped. And the way this works is the machine learning engine builds a model that represents the normal count of events coming from Audit Beat, and it lets us know if it finds an actual observation that is significantly different from what the model predicted. And in this case, that's exactly what happened. So let's click on this link again, just like before. We're going to go to Kibana. And when we do, we're not going to just be in a dashboard this time, but we're going to be in the machine learning app within Kibana. And you'll see over on the left-hand side, the machine learning app has a number of different views. We happen to be in the Anomaly Explorer view, which is handy when you're investigating a newly detected anomaly. And what we're looking at is a construct called the anomaly timeline, where the time period over which the analysis took place is divided up into equal-sized time chunks. And each one is color-coded based on how unusual the modeled entity was during that time period. And so if we look overall, the red being the quartile of a normalized 0 to 100 scale that represents the most unusual, we see that we had a very unusual time period back on February 2nd. And down below, if we break it out by host name, we see that was contributed to almost entirely by Swift Crypto Web 01. So one of the things I can do to further investigate this, if I simply click on that anomalous time period, what is given to me down below is a graph that shows the actual rate of and again, this is a simple job, just looking at the count of events. But you do see here, we had this time period where the events were dropped out altogether. So again, there are other ways to detect zeros, but think about this as being a really smart job because it can detect things that are unusual for the time of day or the day of week. If you have an environment where a signal is normally 0 for some time period, then this becomes super, super helpful. I can expand. Let me look at all of my events here. And one of the things that I can do is it will actually show me unexpected 0 values, but it also lets me know what the typical values are. So I can get all the details about the detected anomaly here. I can see how unusual it is on a probability scale. That's a really, really tiny number, which is why we convert this over to a normalized anomaly score to make it much easier to consume. And one of the cool things that I can do is over here on any anomaly, I can go investigate that either in regular dashboards or in this case, I can go investigate it in the new SIEM app. So if I go ahead and click on that, it's going to take me, again, into Kibana, but in this time, I'm not in a dashboard, I'm not in machine learning, but I'm in the SIEM app that Andrew showed us just a glimpse of earlier. And so I do see some activity hosts associated with that host, Swift Crypto Web 01. I see a variety of successful and failed authentications. I see the number of IP addresses that it's communicating with. I got some indication of the authentications that are taking place on that system. And I've got some of the overall events. If I wanted to, I could open up a timeline and start my investigation. But we're going to actually leave that because we're going to cover that in some more detail in just a little bit. Before I do that, let's go. It turns out that the Swift Crypto team had another automation in play, and they knew for this particular event that if the watch that generated the Slack notification and that saw the high scoring anomaly detected by this machine learning job, that meant that they stopped seeing audit beat events, they wanted to initiate a restart of their audit beat instances. And they had this is a very, very basic form of security orchestration and automated response. So for example, if I go up in the top left to the Discover panel, one of the things that I can do is take a look at any of the activity that I have that's associated with this SOAR activity. If I go ahead and open a save search, over on the right, I've got my SOAR operations. And if I just change my time period to the time when the attack was going on, you'll see that I actually have a couple events in here. In fact, you can see earlier the blocked event that we did during the first alert that we investigated is here. And here we see audit beat being restarted by this automation. Again, it's kind of a real basic version of an orchestrated or automated response. So, all right, what have we got so far? Let's go back to our to Slack and see what's next. All right, we're going to get there. One of the things that when we do get back there, we're going to see is we're going to see the next one, which is a login from a user on vacation. So let's go back to Slack, and the next alert that we see is that login from user on vacation detected. So at this point, we've seen a bunch of attempted logins, right? We've seen a dropout of audit D, a little bit suspicious, but still nothing that's confirmed bad. This next alert re-raised our suspicion that something might be going on. Now, yes, I know most of us will say, well, that's not that unusual. All of us log in during vacation. So just put that aside for a moment and let's take a look at this alert. Wazoo, which is a host intrusion detection system that's evolved from OSSec, at ingestion time, the Wazoo events are being enriched using the JDBC log stash filter, which hits a database of employee work and holiday times. And a subsequent Elastic alert is generated when occurrences of logins where the user is on vacation are detected. So, for example, as I mentioned before, if you wanted to look at the Hive case associated with this, you can simply click on the go to case here. This will take us to Hive. We've got case number 11 that was originated. This was also automatically generated by the watch. So when the watch triggered, it was doing a number of things, right? It was starting this case as well as implementing that SOAR actions. They can all be done within the watch. Let's go back to the login here, the alert link itself, and let's go investigate this one. So this time I'm going to click on the login link as from the user on vacation. And as you guessed it, we're back in Kibana, but this time we're in Discover, so we can take a look at the actual event itself. Again, we notice a few things. This event is stored in Elastic Common Schema format. You see that in the index pattern name up top. We've got a pretty cool enrichment being done here in Logstash, where the username used for this login is actually checked against the haveibeenpwned.com API and is marked and tagged appropriately. So if you see in this field down here, let me make this a little bit bigger. If you see breached account true, that's because we had a match during the ingestion time enrichment. So this is pretty useful. If you find out that the account associated with this event has been previously breached on another site, that might be interesting because adversaries frequently harvest those credentials and try them on other sites, presuming or betting that the users may have used the same password on multiple sites. So that's pretty cool. Right up above the on vacation link, this is the one I described earlier that's being done during the ingestion process to match with a yes. So right off the bat, I've got something pretty interesting, right? I've got a user on vacation that's logging in, and I have a breached account. So this is already suspicious. So one of the things we can do here is we've embedded a link right into the SIEM app, right inside this event itself. So if we wanted to, we could go take a look at it in the SIEM app itself. And in fact, I'm going to do that. I'm going to click on that link. Again, back in Kibana, we're in the SIEM app. And one of the things that we can do, we immediately notice that there is exactly one successful login here, which means this probably wasn't a brute force password cracking attack. This is either user Jacob Doe logging in from vacation at Bora Bora, or he is, somebody's got stolen credentials and has used them to log in. So we're going to want to investigate this one a little bit, right? If I look down, I do see this authentication with Jacob.Doe. I do have some process information here that I could look around at, but I've got this cool timeline for me to start to do this investigation. So one of the first things I can do is I can take this Jacob.Doe and simply drag his user ID into the window over here for investigation. And I can start to look. I've got about 141 events. I can start to look to see if there's anything interesting to take a look at. I'm going to make this just a little bit smaller so I can see it. Okay. And a couple of things that we see here, there are some interesting processes being used. There's one called lesspipe.sh. I can drag this right up as a logical and condition and narrow my search down. Now I've only got about 10 events left. I can start to look through those particular events. And I do see something pretty interesting here. Look at this one where I've got a process title, which is create DNS and CRT, maybe that certificate.sh. So I can take a closer look at that by expanding it. One of the things that I might want to do is keep track of my work. So I can immediately give a title to this investigation. I can call it something like bad login with jacob.doe. I can go ahead and expand this event, look at it in tabular form. When I look down below, I'm going to I want to learn more about that process. So I'm going to go to the process related fields. I do see the process arguments. I see that there was a script being executed, and it's this thing that's create DNS and CRT. Now, up until this time, I haven't been too concerned about what I've seen, but this looks like Jacob.doe might be doing something pretty bad. In fact, he might be attempting to set up a swiftcrypto.com phishing site that will appear legitimate in terms of DNS and TLS certs. This is getting pretty serious. So one of the things that we can do is we can actually tag this investigation and send it off to incident response. So what I'm going to do is I'm going to go ahead and add a note, and Andrew will show you some more details about this later. But I've got a login that basically says, hey, incident response team, please investigate this at high priority. We've got a login from a previously breached email address occurred while the user was on vacation, started executing scripts that appeared to be manipulating DNS and certificates. So I go ahead and save this note. My timeline is then going to be saved off. So our demo is coming to a close. So let's kind of summarize. In the end, it turned out that exactly what the attacker was doing was setting up a phishing site to continue his quest to do harm to swiftcrypto.com. The Swift Crypto team found and stopped him in time by using, certainly with the aid of Elastic SIEM. And one of the things that took place there was that we did have some success. You saw, if you're familiar with the Elastic Stack, a couple places where the SIEM app was used, and these are looking pretty new. So in our next section of our webinar, we're going to hear from one of our developers working on Elastic SIEM to tell us how it helps security analysts get their work done. Andrew, are you ready to take over?
I am. Thanks, Mike. Hello, my name is Andrew Goldstein. I'm a developer on the SIEM team at Elastic. Today I'm going to talk a bit about the design and development of the new Elastic SIEM app with a focus on the timeline. So we're looking at the host view in the SIEM app, which starts out with a bird's eye view of the activity across all the hosts in your deployment. As Mike showed us earlier, we can filter the host view with the search bar at the top, but where we go from here depends on what we're searching for, which abstractly is the truth told by the stories hidden in the actual logs and events. So to help you search faster, so you can do it as many times as possible throughout your day, the team designed a search experience that combines traditional text-based search with a visual query builder that's deeply integrated with drag and drop throughout the SIEM app and powered by the Elastic Common Schema. So to get started, let's drag a user to the timeline. So we're now looking at the default set of fields available in the timeline. These, again, are all based on the Elastic Common Schema. And right away, I can start customizing this view by dragging and dropping. I can resize the columns. But if I click here on the Fields browser, because the Elastic Common Schema organizes all of the fields by category, I can actually browse the entirety of the Elastic Common Schema, as well as any user-defined fields that are available in any of the indexes configured to work with the SIEM app, like Andrew K. showed us earlier. So I'll click on the agent category here, and now I can scroll through, see all of the fields in this category, their descriptions, and if I wanted to add any one of these fields, once again, I can just drag and drop it here. And now our timeline's been updated to include this new field. From here, I can pivot this into a search by dragging and dropping it to an and. And so now we can see we're looking at the events for user Bob, and the agent is Autobeat. But just for a second, I'm going to close the timeline to show that it follows you around the SIEM app. And we're once again here looking at the host page. I can drill down into, let's drill down into a particular host here. And now we're looking at the host details view for a host. Now we're seeing a summary of that host, the authentications that are occurring on there, any uncommon processes associated with it, and the events specific to it. And anything that I see on screen here that's interesting, for example, a host OS family, or in this case, a cloud region where this particular host is running, I can just drag and drop that to the timeline, open it back up. And now that we can see our query still includes our original search criteria of our user Bob, but now it's been ORed with this cloud field that I just dragged from the host details view. Now from there, I can click on this and negate this field, which is a pretty common thing we do when we're threat hunting. I can change it entirely to an exist search, and further, if I wanted to, I could even negate that itself. But for now, let's clear this filter and let's focus a little bit on the events themselves. So right now I'm looking at a single event. And if I click here, I can expand it to see all of the fields. It is, of course, Elasticsearch behind the scenes. So here's our documents JSON view. But if I go back to the table view, you'll notice that we have all of the fields and values that are particular to this event, as well as their description. So you can easily follow along and discover the data model over time. Now, if I wanted to further customize my timeline, like for example, adding this ID field, I can drag and drop it to the top here. And now all of my events include ID. Again, I can further rearrange things. But if we expand this field one more time, I want to demonstrate that I can also take any of the values that I see in this individual event, for example, this host name, and I can drag and drop it up to the timeline and further filter my view as we go. So now let's talk a bit about a new visual storytelling technology unique to Elastic SIEM called event renderers. Event renderers tell the stories in each event that until now you had to piece together manually. So while I showed you just before how I can quickly customize the view, you'll notice that I didn't do any work here to view this summary of this particular event. So let's break it down a little bit in the sentence form that this event renderer is describing. So for this session, this user at this host in this directory opened this file using this program, and the attempt was successful. So that's about 7 fields. And you'll notice that I didn't have to rearrange any of these fields, for example, this file path, in order to view them. The event renderer did all of that work for me. So once again, just for a moment, I'm going to close the timeline. Let's navigate back to the host view. And actually, let's create a brand new timeline. And this time I see I have an IoT device. So let's drag and drop it to the timeline and start looking at it. Now, this event here is another example of an event that's rendered with a row renderer. And this is one that we call our NetFlow row renderer. So, once again, if I wanted to, I could expand this event. I could see all of the details in it. But if you've ever picked apart NetFlow data or network traffic, I mean, it's a little bit of work to get that to get at that story in an individual event. So the NetFlow row renderer is taking care of that storytelling for us. If I hover over here, I know that at a glance the duration of the event, its start and end time. And I'll point out that when I hover over this date field, or if I hover over this one, for example, the Elastic SIEM app is doing the quick date math for you. It's telling you how long ago it was. It's doing time zone translations. And that's because as developers, we were doing hundreds of searches a day, and we were getting pretty tired of doing all that date math in our head, and we figured as users you are too, so we do it for you. Now, going back to this event here, the event renderer has surfaced the directionality of the event, so we know that it's internal, the protocol is DNS, and these arrows between the source and destination, the thickness of them is showing us the relative percentage of traffic going between the source and destination. So at a glance, we can get an idea of what's happening. Now further, because we have a network community ID, I can drag and drop this into the timeline and then filter to see only traffic related to this flow. But I'll unfilter it really quick here. And again, because the timeline is deeply integrated with the rest of the SIEM app, we started our search from here, from the host page. But if I click on this IP address, and I'll close the timeline for just a second, now we're looking at the network details page for this IP address. We're seeing fields and data that we've gathered automatically. And then if I re-expand my timeline, if I see anything interesting, for example, this issuer, I can drag and drop it back here and continue my search. Now, from here, I'll point out a few other details about this particular row renderer. For example, in this case, we're seeing geolocated data. Once again, if something's interesting, I can pivot right from here into my search. And now I'm looking at just data going to this IP address. And I can see here, again, another example of the row renderer surfacing details that are interesting. There's a JA3 hash associated with this event. If I click on it, it navigates to an external site where it's checking it against a blacklist, so I can quickly see whether or not this is something that is worth interesting and investigating further. And so this is an example of another row renderer. So let's clear the timeline. And this time, I'd like to demonstrate that the timeline can also be used to start an investigation. So in contrast to our previous searches, which we started from the SIEM app itself, we can use the KQL filter here to kick off a search right from the timeline. The KQL filter works in combination with drag and drop. And if I want, I can change the way that behavior to work as a filter or as a search, so to AND or it. In this case, we'll leave it as an AND. And what we're looking at here now are examples of data. Let's actually resize this here so we can see this. We're looking at examples of data rendered with the Suricata row renderer. So in this case, the Suricata alert is visible right here. I didn't need to rearrange my timeline in order to see it. And because this event looks particularly interesting, let's take this network community ID, drag and drop it to the timeline, query builder at the top. And now you can see that we are combining this visual query and this text query to look at only the events related to this particular flow. I can resort based on time or on some of these other fields here. But at this point, this is looking pretty interesting. And so I might start contacting my colleagues, start collaborating on a timeline. And I want to add a little bit of context based on what I learn in my conversations with my colleagues. So one thing I'll do first is pin some of these events. Pinning events is a way of flagging particular events of interest that have been added to a timeline. And now if I click on the comment button, I can add a note. In this case, here's some context. The user was out of office, similar to the scenario that Mike showed us earlier. I click the add note button. And now right in here, right alongside the data, is that note in context. Because it's Markdown, we can get pretty fancy with the formatting of this if we want to. In this case, I'm going to paste in a link to a GIF just to show you some of that more advanced formatting, because we all like animated GIFs. So here's an example of, this GIF actually is an example of me adding a data to the timeline, so kind of like a recursive little thing here. But at this point, we want to share this search with our analysts. So let's once again give this timeline a title. I can give it a description. I can optionally favorite it, although I won't in this case. And as Mike showed us earlier, I can add notes to this timeline that are applicable to the entire timeline itself, in contrast to the notes that we added at the individual field level. And again, because it's Markdown, I can add headings, I can add, quote another user, add tables, and now all of that's been captured as a note in this timeline. So let's create a new timeline just to clear this for a moment. And now I'm going to navigate to the timelines page. So the timeline page collects all of our timelines, which are automatically saved as you create and update them. And here's the timeline we just created. If I expand it, I can see all of the notes that we added, including all of the rich formatting. I'll collapse this. If I click on this, it's going to reopen the timeline, and now I can continue my investigation, add new notes. And from here, I think it's also worth noting that timelines are secured by Kibana spaces. So only users granted access to the same Kibana space can view and collaborate on a timeline, and you can create as many of these spaces as your organization needs. So to wrap up, I'm going to filter this view by favorites. And because timelines are saved searches, now you can see that I've filtered this view to include only my favorite searches. I can use them as starting points now to kick off new investigations and or open an existing one and continue to investigate and collaborate with my peers. So with that, on behalf of the development team, thank you for the opportunity to share our thoughts behind the design of the timeline and the Elastic SIEM. I'm going to throw it back to Mark now for some Q&A.
Super.
Mark?
Thanks, Andrew. And we will stay on for as long as we're getting great questions. We have a whole bunch that we've received over the course of the past 45 minutes. I'm going to go ahead and get started with a pretty easy one. And this is one I should have covered right at the top. How is Elastic SIEM licensed? Is it available for free? Well, the Elastic SIEM app is available in our default distribution. Elastic Common Schema, it itself is entirely open source. Everything that you've seen today is available to end users. Some of certain things like machine learning and Watcher require a subscription, but the SIEM app itself, Elastic Common Schema, the real basics of how we're making it easier to use Elastic for security analytics is freely available to end users. So you can access it in Elastic Cloud or by downloading our default distribution. We also have a question about if there's a specific version of the stack that you need to be on to use Elastic SIEM. Well, ECS is supported in 7.0 with many new data sources being added with every release. At this point, Beats is fully supported by ECS, the 1.0 spec of ECS. The SIEM app itself, it requires 7.2, and I think you're going to see in future releases a piece of enhancement, a pace of advancement with our SIEM app and with other security functionality that's going to make you want to always be on the latest version of the stack. We're not one of those organizations that has a new release every 8 to 12 months, promises it every 6 months and gets it to you every 8 to 12 months. We're trying to get a new release out there really regularly and have material enhancements that make you glad that they partnered with us. Let me throw my next questions to Mike Paquette. We have a couple of questions about what roadmap looks like. These are pretty high level, but I want to get them answered. When do you folks expect to develop the features mentioned in the roadmap? And do you have any plans to share a public roadmap for the SIEM capability, something more specific than we've already shown, something along the lines of maybe AWS's container roadmap? So when do we plan to develop the features we've mentioned? And do we plan to get more specific in a public way? Mike, let me throw it to you.
Sure thing. The roadmap, as you shared at the beginning of the presentation, Mark, provides directional indications as to the types of features that we will be developing. All of Elastic's software that's related to this is developed in public GitHub repos. And so what we would do is ask our users to track along and follow in the GitHub repos to see what's being worked on, to raise issues for features that they'd like to see implemented, tag those with an enhancement tag so that we can work on them. And I think they'll be able to follow along with us. But no, there are no plans to share a public long-term roadmap with any specific dates or releases.
Okay, good stuff. We have a couple questions about whether we're going to be a Black Hat DEF CON B-sides. We'll be at the big events in Las Vegas taking place in early August, at least in the United States, they're big events. There's a question about whether we are doing a SIEM demo at DEF CON entitled Threat Hunting with Elastic Stack, a class at the Blue Team Village. I know we're doing a bunch of different stuff at DEF CON and at Black Hat. Does that specific class ring a bell to you, Mike? Threat Hunting with Elastic Stack?
It may be. So I'm not 100% sure. So we'll have to find out on that.
Okay. Beats, Andrew Kroh. We have a bunch of questions about Beats and about ECS. So first one is, how do Beats agents communicate with Elastic Cloud? Is it via HTTPS like TCP 443 or is it something else?
Yeah, the direct communication from Beats to Elastic Cloud is done over HTTPS. And it can be sent over 9243 or Elastic Cloud. Also, the load balancers are also listening on 443. So you can use either. It might be easier to use 443 so you don't have to open up firewall rules.
Super. So we have a couple questions about how Beats data is getting, how it's what our support for ECS is within Kibana and elsewhere. So obviously the SIEM app itself uses ECS and Beats is coming in ECS format. Are there other areas within Kibana where ECS is enabled? How ubiquitous is ECS within the larger solution?
Is that for me?
Yeah, we'll try that.
Yeah. I mean, we've updated on the Beats side, so the things that produce data are in ECS format. There weren't too many changes within Kibana so it was already so general, so it could handle any sort of fields, whether they're ECS or they're your own custom fields. And we still have a little bit of work to do within Logstash, so we're still trying to update some of those modules on the Logstash side to send ECS data. So that's where we are.
Super. I'll say that we are wherever it's possible for us to use ECS, and we've built it to operate in as general a way as possible to meet the different use cases that we have. Wherever we can use ECS, we are using ECS. ECS is going to be at the foundation of any content that might be released. We would expect ECS to be when the community develops content for it to be developed on ECS. So it is an inclusive spec. That means that we have the ability to customize it where necessary, but we've put a lot of thought into building what ECS is, and we don't expect that to be necessary most of the time. So really encourage you where it's possible for you to adopt ECS to go ahead and do so, because it's going to pay dividends in the functionality that you see from us and the ease of adopting that functionality. Someone's saying that he or she is a pretty new ELK user, but they've worked with many different SIEMs. They're wondering how to extract fields from already indexed data. what do they need to do to extract new fields from already available data that is inside of Elasticsearch? Mike or Andrew Kroh?
Andrew, you want me to give that one a shot?
Yeah, please go ahead.
So Elastic is a little different than other SIEMs you may be familiar with in the sense that there's an index mapping template that is applied. So in general, the indexing is done at ingestion time. So the idea is that if you have a template that's doing, that basically specifies your keywords and your other fields to be indexed, you don't need to extract the fields because it's already available for you. They're already in the documents and they're already indexed. So one of the wonderful advantages of Elasticsearch as a platform for SIEM is this indexing everything at ingestion time. Which means you don't need to go through those secondary operations of data that maybe have been ingested but not indexed. So there may be some subtleties in that question, but I just think that's the overriding concern is you don't generally have to deal with it that way.
Super, Mike. I'm gonna throw another one to you. We have lots of questions, pretty specific data sources, everything from CloudTrail to Fortinet, SonicWall, Ceph, Cisco ASA logs. Some of those obviously we already provide support for. But if how can someone find out if we provide kind of out of the box support for a data source, and if that support does not yet exist, what can they do to bring that data into their system and to parse it with ECS?
So the general approach is, Andrew described earlier a lot of the ingestions that we already have that are producing ECS formatted events. But the process by which you take your existing data source, let's say you have an ingestion pipeline that's using Logstash, it's a modification to the Logstash config that creates the logical mapping from your existing field names to the ECS field names. With regards to Ceph, we don't have a out of the box version. However, in the ECS repo, there is an issue that provides a logical mapping from Ceph fields to Elastic Common Schema, and a number of our customers have already implemented that. So that may be something that we do in the future. It's not available today. Same goes for some of the other sources. I see the question on, their support plan for other logs, antivirus logs, internet filtering, mail tracking, and will ECS be adapted to support information for such logs? The answer is yes. ECS is it's generally available as a specification, but there are areas in which it will expand going forward. So we have an active team working on Elastic Common Schema in concert with our community, and we do expect to add more field sets to ECS going forward. So yes, you should not only keep an eye on that, but if you have interest or you've got a proof of concept, why not participate in the ECS repo and put up your sample mapping because you may have done some good homework that would help other members of the community. Cisco ASA log ingestion. So we talked earlier about the FileBeat module for Cisco ASA. Could it be done in Logstash too? Yes, absolutely. We don't have such a configuration available, but you could take the logical mappings that are used in the FileBeat module and use those in your Logstash config. Absolutely, yes. SonicWall, many future firewalls are on the list of new sources. And then there's the question about Ceph. So so I think the answer is we've gone over the list that are available out of the box today, and then the others can be created with help of Elastic or with help of the community.
Awesome. Yeah, lots of great work happening. Yeah. Besides, Mike, you mentioned that if someone does some mapping and wants to share that homework within the repo, please go ahead and do so. The other thing that we would find helpful is if you find something within the spec itself or that you'd like to ask a question about or ask for clarification on, go ahead and file an issue within the repo. If you have the question, there's a good chance someone else does too. And if there's a different data source that maybe you don't have the time or energy to go ahead and get that mapping done yourself, it's helpful for you to file that for us, even if you're unable to do the work yourself, because someone else might see that, someone else might be able to tackle it. A huge strength of Elastic is our community, and you can contribute to that community just by telling us what your requirements are and where possible, helping us meet those requirements. Let's see. Quick question about Andrew. You were asked a question about where you added an index so that the SIEM sees the log. Looks management advanced settings SIEM. So it's just inside the SIEM app itself where you can define the indices. Is that right?
That's right. Yeah, it's part of Kibana's advanced settings.
Okay, sweet. So let's get to some good alerting stuff. So, Mike, we have a question about whether one can write their own use cases for Watcher.
Sometimes the word use case is used to describe a detection rule or a SIM detection. And in that context, the answer is absolutely yes. Watcher is absolutely extremely flexible to set up detections based on pretty much anything you could search with an Elasticsearch query. And as was shown during my demonstration, it's extremely flexible in terms of what can be done with the actions once that watch has been triggered. We saw things like, of course, writing notifications to Slack, creating cases in incident response systems, and even taking some forms of responsive actions. So the answer is yes. You can develop all the watches that you like. As Mark mentioned earlier, Elastic Alerting is a subscription-based feature, so that particular feature is not free to end users. So yeah, Mark, does that answer that one?
I think it does. A couple more on Watcher. Some might be forward-looking, but one question: does Elastic SIEM correlate attacks across different log types and indices?
So a couple things. So the general answer is yes. You may have noticed, and Andrew Goldstein, when he was talking about this, when he was using that timeline, that data was coming from multiple indices. In fact, the indices could have been specified by the end user themselves. And the goal of Elastic SIEM is so that the security analyst and investigator don't need to know about the underlying infrastructure of things like indices. So in all those searches that I did and that Andrew did, we were absolutely searching across multiple indices and pulling back the relevant data in order so that the analyst could get their questions answered without having to worry about indices.
Super. We did have a question about getting the code to format Slack notifications. I wanted to mention that there is documentation on our on elastic.co for integrating with Slack. And in addition, I have reached out to the developer of the Slack integration. He is currently on his honeymoon. So when he gets back, I will ask him if between, when he's not doing his day job, if he might be able to write up a blog post about how he developed those awesome Slack notifications. So hopefully something to look forward to there. We have a couple kind of entity-related questions. Mike, I don't know if it's worth going into detail here, but questions about setting up Watcher for a group of users, or defining, understanding when a user will be on vacation, that sort of thing. Is there anything, any guidance that we can provide there?
So using Watcher, it is possible to set up those types of things right now. So yes, will there be an implementation of alerts based on a query without the requirement to set up an entire alert in Watcher? So a couple of things towards that question. So Andrew Goldstein showed us how an existing timeline could be used as essentially like a saved search to beginning an investigation. That same capability we would expect in the future. When Mark showed the roadmap, we talked about additional detection mechanisms. I think that's kind of a roadmap feature to be able to see that kind of functionality in the future. Super.
A couple questions on spaces. Michael, I'm going to turn this to you again. So you can create read-only access to spaces, right? This user isn't using spaces yet, but is interested in doing so. And also ask if we have any guidance on a good strategy for spaces within a SOC, like a space for content development, space for analysts, maybe different tiers of analysts. Any guidance around how best to use spaces for a SOC?
It's a wonderful question, and it's probably a topic beyond the scope of a webinar answer to have a discussion on that. Certainly, you need to take into account the role of the individual as well as the sensitivity of the data. And also has to do with index lifecycle management and access controls to indices. So unfortunately, there's not a quick answer to that one, and it may be a topic to pick up on the Discuss forum.
Okay, super. SOAR, a couple of great questions around SOAR. What are the plans for SOAR with Elastic? And organizations, if they have their own custom SOAR workflows, maybe with a third-party tool, how do we provide support for those workflows?
So the Elastic Stack, including the SIEM app, are being developed always API first, so that third-party tools like security orchestration, automated response tools will have access to the data. Watcher has powerful notification and communication mechanisms through webhook APIs and other sorts. So the ability to integrate your existing SOAR workflows exists today. We've got a number of integrations with commercial and open source SOAR vendors and projects. So that will continue. Over time, you saw some of the basic capabilities illustrated today. I mean, some of the basic capabilities exist today in Elastic, and there could be additional future features that would make that even more automated.
Super. One part of that, in answering a question that we received about whether it's possible to export a timeline for historical purposes, the answer is yes. It's something that I think Andrew Goldstein alluded to. We have the ability to store, to export data, for that as an investigation to one of the tools that Mike mentioned, with connections available through API. One of the advantages of like our huge user base is that if you're a SOAR vendor, you're going to want to integrate with the Elastic Stack because so many different organizations use it for security and for other use cases. So typically, whether you're trying to, like we have the attentions of the Demistos and cyber responses and SOC primes and swim lanes of the world. And if whether you need to integrate with them or ServiceNow or something else, you're going to find that that when they help you integrate with your Elastic Stack, it won't be the first time they've done so. There is a question about a SOAR platform from Elastic. We're committed to enhancing our SIEM app and making it possible for an analyst to do as much work as possible within Kibana. I don't know that we would say that we, Mike, maybe you can correct me on this, but I wouldn't say that we necessarily have plans to develop what we call our own SOAR platform, but we do have plans to make it possible for security analysts to do a significant amount of their work within Elastic and to integrate tightly with the tools that they use for downstream workflows. Do you think that's a fair way of putting it?
Yeah, I think at this point it's premature to project whether that will or won't happen. So it's a relevant area, and but no plans in place yet.
Fair. So we have a handful of other questions that are coming in on topics that we've kind of discussed. Integrations, do they exist with new technologies? What are our plans for specific integrations, that sort of thing? I would encourage everybody to ask those questions within the Discuss forum. We have a SIEM channel on the Discuss forum, which is kind of our online community. I would encourage you to join our meetups and participate in the Meet Space community as well for Elastic and our place within the security world. And I would encourage you to keep an eye out for webinars and blog posts about security. I'm going to go ahead and suggest that we wrap up this webinar. I really appreciate everybody joining. We'll stick around in IRC for just a few more minutes to try to answer any questions that remain. But thank you everybody for joining, and thanks to our presenters today.